Hi guys, today I'm going to be checking out these batteries. I've actually got 18 of them and I'm going to check them out to see how good they are using an internal resistance check. And what I'm going to use is my multimeter and this little power resistor. It's a 120 ohm resistor and it's rated at 10 watts. So that's more than enough to be able to test these batteries with. Okay, so to determine the wattage of the little power resistor to be able to hold the current, we use Ohm's Law, which is volts over current over R, which is the resistance. So we know the volts on these ones are 12 volts. So put 12 volts there, and that is divided by the resistance, which is 120 on that little power resistor. So it's divided by 120 equals 0.1. So we times that again by the volts. So times that by 12, we end up with 1.2, and that is 1.2 is the current. So that's 1.2 watts. So just make sure when you use one of these resistors that the wattage is capable of holding that current. So this is 10 watts, so that's more than enough for the 1.2 potentially going through the circuit. Let's wire up this battery. So I'm going to put two test leads on here, one on the positive, one on the negative. I'm going to wire up the test leads, positive to positive, negative to negative. Okay, so on there you can see 12.67 volts, or 12.66. So mark that down on our sheet here. So 12.66 is V1, and this is the formula I'm going to use here to work out the internal resistance. So that's our starting voltage, 12.66. So what we do next, take these leads and the little resistor, pop it over the resistor in and out, and what I'm going to do is watch that voltage until it settles down a little bit. It will keep dropping because obviously the current is going through the resistor, but once it starts to slow and seems to settle, then we'll take that reading. So there you go, but 12.36, sorry. So V2 was 12.36 V2. Now what we do is use this formula. So you've got V1 take away V2. So you've got V1 take away V2 divided by V2. So we'll do that. So we've got 12.66. Get a calculator. There we go. 12.66 take away 12.36 equals 0.3. So then you want to divide that by V2. So divide by 12.36 equals 0.024. And with that you times it by the resistance. Sorry, there you go. Times that by resistance, which is 120 ohms. Times by 120, and we end up with a figure of 291, and that is ohms. So that is the internal resistance of that 12 volt battery, 291. So what I'm going to do, I've got 18 more batteries to test in exactly the same way, and then we'll have a look at the results after. I've done my tests on 18 batteries, and these are the figures. This is the column I'm more interested in. So there's the open voltages the resistance, voltage, and that's the internal resistance figures here. And the majority of them look pretty good actually. Everything seems to be about 2 or 3 ohm resistance, except for a couple of them. So this one here, number 12, battery number 12, was 140, and that's obviously pretty high. And you can see the voltage drop. It was 1175 and went down to 5.42, so that's a massive drop. So there's a lot of internal resistance with that battery, so that will be going for recycling. And number 18, not so much of a drop, but still on the high side when you sort of compare it with all the other ones. So I don't think I'll be keeping that one either. I'll get rid of that one. Another interesting one, it seems number 16 has the lowest resistance of 2.18. Now this is interesting, and I'll show you why. Okay, so this is battery number 1, and it's charging perfectly fine. I'm using a little boost buck converter here to regulate the current from the 12 volt charger to 13.8, which is a float charge, which keeps it nice and topped up. And as you can see, 13.8 on the meter. However, number 16 battery, the one with the lowest internal resistance, shows this. So yeah, this is battery number 16. However, it's only 12.04 on the multimeter. So for some reason it's actually resisting the charge from the boost buck converter here, and I'm not too sure why. But anyway, because there is a bit of a difference there, I don't think I'll be using this battery either. There's obviously something going on inside that it doesn't like to be charged. So although it's got a low internal resistance, I think I'll be recycling this one too. Well, I hope you found that interesting, guys, and I'll see you on the next one.